I'm going to talk about Azure Synapse Analytics and how can we migrate data from SQL Server to Azure Synapse. That's my main topic of the presentation. Whatever I'm going to present today here is purely my opinion, my view. It has nothing to related to the organization. So I work for art, I work for QInsure, but they have no anything on that part. So whatever I'm going to talk about is purely my own personal view. And if you want to connect with me, I'm available on LinkedIn. You can see my LinkedIn profile. I'm a 007 James Bond fan. So Sharma Suraj, last name, first name 007. That's my uh, tag in the LinkedIn. So what are you going to get out of this session? Most important, what I want whenever you go out of this room, I want at least you should have basic understanding. At least basic, because some of you have just as I've asked in the beginning, only 3 of you have used or planning to use Synapse in the near future, but others they have never used Synapse. So that means they are very newbie or a starting on the journey on the cloud. So I want to start presentation keeping in mind that people are also sitting, they are coming from a totally from zero. So I have to make presentation in a view that they also get engaged into the presentation. If I go into too much of technicality, they'll be saying, "Oh, I'm missing out." So what I'm going to cover, I'm going to cover both starting from beginner levels to the advanced level, and I'm going to cover some topics and going to share some tips so that you can apply in your real life project. So the agenda for the webinar or the this meetup. First, I'm going to talk about what is Azure Synapse and what is feature. What are the benefits you are going to get out of it if you want to migrate to Azure Synapse? Because there are a lot of database available. What's the need? Why we want to migrate to Azure Synapse? If you have decided, you have done your POC, that you have compared the other competitors available in the market, Snowflake, Redshift, and Synapse, and you have decided, okay, we have to go with Synapse. So you have done your POC. So how can we migrate now? What are the migration guide? What are things you should look for? And at the last, the best practices. If you don't have best practices, you are going overspending money on the Azure. So make sure that the best practices are followed. And finally, I'm going to conclude my presentation. So overview of Azure and Synapse. So what is Azure Synapse? Generally, one thing that comes to my mind, everyone's mind when talk about Azure Synapse, it's just a database. First, I want to clear from everyone's mind is Azure Synapse is not just a database. Database is one component of it, but it's not purely a database. Azure Synapse is nothing but an analytical service, which have lot of many products combined together that was working in silos in the past. That if I have to name something that was working in the silos in the past is Azure Data Factory, Power BI, Databricks, and all those things working in the silos. So what Microsoft had done, Microsoft have bought all those components together and bought into one product. So Synapse, Azure Synapse is an analytical service that accelerates your time to ingest data from across sources, and it can work with the big data and everything. So if I go to the next slide, so this is the ecosystem of Azure Synapse. So in Azure Synapse umbrella, it's a combination of 4 different products at a high level. Now we call Synapse Pipeline. This is nothing but the ADF Data Factory. They have bought the ADF component into the Synapse and they have called as a Synapse Pipeline. Ideally, almost everything is same between ADF pipeline and Synapse pipeline. Everything features, look-wise, and everything is absolutely the same. So if you have spin up the Synapse workspace, you don't have to spin up the new ADF instance. You can get everything working in the Synapse pipeline. There's a small catch, only one component which is not supported in Synapse pipeline. The second thing, they bought the Power BI inside the Synapse umbrella. They bought the machine learning. They have bought the own Azure Spark pools so that you can do machine learning, AI, and all those kind of things within the Synapse. And and they have the Azure Data Lake storage. They have combined the storage within the Synapse. So instead of moving across different places, you can just log into one Synapse workspace and you can connect to everything. So that's the main ecosystem of Azure Synapse. Before I go into my main focus of this presentation is talking about migrating SQL Server data. So what we are going to cover in this webinar, in this meetup, we are planning to migrate the data from SQL Server to a SQL side on Synapse. And that component is called Synapse Dedicated Pool or Synapse uh, uh, SQL Server DW, something like that. In the previously, people used to call Data Warehouse DW, something like that. They have renamed and this called Synapse Dedicated Pool. So what's the difference between these two? Why we want to migrate? What benefits we are going to get out of it? So first of all, the SQL servers that we use currently on the on-premise, it is a SMP architecture, or are you using the managed instance, or using the hyperscale? So those databases are of architecture called SMP. But if you go to Synapse or Redshift or Snowflakes, that architecture is totally changed. That becomes MPP, massively parallel processing. That's the main difference between those two. So what is SMP and what is MPP? So in an SMP system, each processors share the same resources. That is what SMP. While in case of MPP system, each process has its own dedicated processor, own memory, own share resources. They do not share anything. So they have their own standalone system. So as you can see here on the screen on the image itself. So in the SMP architecture, one instance share the same database, but in the here we have a combination of pool of systems, and they are not related to each other. So it is a composed of multiple machines, not just one large system. And MPP are loosely coupled from the processor and the database on the storage side. So what's the difference between now I'm going into more deep now. We've talked about Synapse. What are the features the Synapse has? Now we talked about Synapse dedicated pool, but also Synapse provide another component called serverless SQL pool. So what's the difference between these two? Why, at what sense we have to use the dedicated pool? At what sense we have to use the serverless SQL pool? So as you can see on the screen, serverless pool is like you getting charged from Azure by per query. So you amount of data movement that happening by the query, you getting charged by that. So what happens as soon as we fire the query, the compute resource is going to spin up, and they are going to depend upon the demand and your query performance. Everything is going to spin up the resources and fire the query, and results are back. When results are back, it is going to scale down. So you are getting charged per query, an amount of data that you are moving, and that's called DPP engine, distributed performance engine. While in case of MPP, dedicated pool system, which is nothing but a standalone database. You have provision, you know that you have a demand that's running 24/7, and I cannot wait for few seconds or few seconds to spin up a cluster that's going to run a query and then going to return back. What I want, as soon as I fire the query, I want the result back. So what you're going to do, you're going to provision a standalone dedicated pool, which is run 24/7. And but there's an option also coming. I'm going to talk in the next step, which can scale up into 24/7, and you can query the data on your term. So as in the slide you can see here, this is the control node on the board. Sorry.
What is the
Dedicated pool and SQL serverless SQL pool?
no?
No, they are different.
Database?
They are different.
SQL Azure.
Yes, they are different.
They are different.
Yes. So that's the difference. That's the difference between those two. So the Azure SQL database are SMP architecture. They are not massive parallel processing, but Synapse is an MPP architecture. That's the main difference. And also a lot of limitation comes with Synapse. Not limitation with SQL Server. You cannot create the external tables. If you want to create an external table pointing to the file sitting on a blob storage location, you can do easily with the Synapse. With Synapse, you can do machine learning, Databricks notebooks, and all those things. But with Azure SQL database, it's purely a database.
Yeah, you can still use open role set
Yes.
specified connection.
Yeah.
Using the same.
Yes. Yeah. So if you talk about that Azure SQL and Synapse, they are two different products. The architecture are totally different between those two. As a database, yes.
You can externally, for example, using SQL.
Yes. So it will come with a endpoint with you, like with the normal Azure SQL DB, you get the server name and the DB name. With with Synapse, you're also going to get the endpoint. So you are going to get the three endpoints now. One endpoint for the dedicated pool, if you have spin up the environment, the dedicated pool. The second you will get for the endpoint for the serverless DB, the serverless SQL pool, and the third one is for the Apache Spark pools. Sorry, what?
Table, you've got MVP for the engine.
Yeah.
For massive, you've got DPP. I didn't pick up what that acronym means.
MPP, dedicated pool is an MPP architecture, but serverless pool is a DPP, which is distributed processing system. So what's happening? They are charging you based on the amount of data movements happening between the query. So you're not getting charged for the compute. You are getting the charge for the amount of data movements happening by the query. Yeah. So as you can see in the on the screen here, it's called a compute node, sorry, control node, compute node, and this storage. So what's the difference between these three? And also you can see there is a term called DMS, data manipulation services. So what's the difference between these three? So control node, whatever you can see on the top of the screen, which is actually nothing but the brain of the architecture. So control node is actually hosts the distributed query engine and which optimize the queries for parallel processing. So it's nothing but the brain. It's passing the information to the control, that compute node, what they have to perform. So this is what it's the control node distribute the query engine and ask the optimizer queries to do the parallel processing. Then that command goes to the compute node, with just the second layer, which is this layer. From here it comes to this layer. And in this layer, what's happened? The control node actually hosts the distributed queries, which query optimize for the parallel processing. The compute nodes actually host all the data that you are underlying storage. So compute node stores all the user data in Azure storage and run the parallel queries. And what's happened in this way? DMS. So let me give you an example. A basic example how to explain this MPP architecture and how this query performing in the real world. So you got a box of cards with 52 cards in it. Okay, and I've spin up a dedicated pool with this compute node called one. So I've given that card. Sorry, David. It was David, right? Ryan. So I've given the Ryan a box of 52 cards, and I said, okay, Ryan, can you find me a diamond, a spade card, a diamond spade? What is going to do is start going to scrolling all the 52 cards and try to find a spade diamond. And depend upon where it's stored, it's going to take time. So if it is the last card, it's going to wait for the 52 card and going to return. What I'm going to do now with the compute parallel processing, with the compute, now I splitted the card, 52 cards, 26 each. So Ryan and with Andrew. Now what happened? I've asked, find me the spade card. What they have to do? They don't have to go and scroll down all 52 cards. They have divided for 26 cards each. So they have to scroll down only 26 times. If the same way continues, I have divided that whole card, say one card each, with the 52 group people, and I've asked them, where's the spade diamond? Someone, whoever has, they just turn around and they see this mine, you can return the result immediately. So that's the parallel processing. What I've done, I've divided the compute across nodes, and they are returning the results immediately. So if you go to the service levels, like which kind of dedicated pool service level we have to use to get the parallel processing benefit out of it. If you are coming from managed instance world, if you are using managed instance on your machine for storing data, or if you are using the hyperscale, so this is a very basic question comes to your mind. What kind of cores which is equivalent to DWU? Because if you're running on 16 cores, if you're running on 32 cores on the hyperscale world, the first thing, how many DW should I spin up to use the Synapse? That is a very basic question comes. So what from my past experience, maybe I'm not correct because this is what we have done in the company. What I have understand, the 32 cores is equivalent to 1000 DWU. If you go scale down a little bit, 16 cores equal to 500 DWU. So why I'm saying this? Because we have ran the workload on those site simultaneously in parallel, and we have started spinning up that cores accordingly. And we found that if you are on 1000 DW and 32 cores, you are going to get the queries running approximately in the same amount of time. So that's how we have decided. There's no concrete documentation available on Microsoft page or any other website that can tell you like this course equivalent to this 1000 DW or something like that. So this is coming from an experience. So if you look at this data management services, what happens if you have only spin up say 4 compute nodes? In this 4 compute nodes, you having the data here. What's happened? This compute node is trying to uh, uh, organize the data. What's going to happen as soon as you fire the command? If you have less compute node and if your data is not properly stored in your database or in your table, which is the distributions, then what's going to happen? The data movement is going to happen across nodes, and that can affect your query performance. So I'm going to cover in the next slide, which is called the distribution. So yeah.
There is a relation between how much of data you have and how many those DW instances you create.
I don't think so any relation with the data, but we have ran the workload approximately on 4 terabyte of data, and we have found the same thing. Yeah, yeah. So from my experience, that's what I'm telling you. We have migrated from hyperscale to Synapse, and in that migration, we have ran the workload that's running on the hyperscale, and we ran the same workload on Synapse. And to get the first criteria to be successful migration, I want to get the same number of duration that's running on the older system, which is the hyperscale system. If our performance is going down, then we have to scale up our the Synapse instance. So we started with 200, 300, 500, 1000. So what we have noticed in this, because we started from with the bare minimum DW, and once we went to 1000 DW, we have noticed that the performance coming approximately the same durations. The delta loads are taking the similar amount of time. So if you have delta loads running in your company, daily delta loads, which are in my old system, it's running close to 4.5 hours. So my success criteria to migrate to the Synapse, I want my delta load, which is running on hyperscale in 4 and 4.5 hours. I want the similar delta load on Synapse should be work in either in 4.5 or less than 4.5. If it is going more, then we are not moving to Synapse. So good part is that we have as soon as we migrated this to 1000 DW without any much uh, performance tuning techniques, we have managed to get the same duration. But after, if you go to Synapse, there are a lot of performance tuning techniques that you can apply. One thing I can tell you, after I applied those performance tuning techniques, we brought the delta load time from 4.5 hours to 1 hour. So that's the benefit that I'm going to get out of this through Synapse. The other problem with hyperscale, you cannot pause. Hyperscale is running 24/7. You can only scale up and down, starting from 2 cores to 32 cores, 64 cores, whatever it is. But Synapse, if database is not in running state, then you can pause the database. You are getting charged only for the amount of hours that you are that's running in the system. Yes. Yes. So I have two experience in this migration process. My personally, I've worked for Queensland Health, where we have migrated data from managed instance to Azure Synapse. There is a limitation there. Managed instance can only hold maximum of 8 terabyte of data. If you are going above 8 terabyte, you have to think about either hyperscale or Synapse. So instead of going to hyperscale, we have at that time we went to Synapse. And where I'm currently working, we have migrated from hyperscale to Synapse. Ideally, they are both SQL version. So they are almost similar to where on-premise SQL Server. Performance is the main thing. The second thing is that cost, security, all those things, scalability, all those things comes into picture. No, cost is different. Yeah, the duration are same. The running the delta load job when I initially migrated, the duration was same. Uh, yeah, course. Yeah, yeah.
Is there underlying technology is Spark?
Yes. So
Can you repeat the questions, please?
sorry.
When they ask the question, if you can repeat it, please.
Yeah, when the
Okay.
audience asks the questions online, can't hear them.
Oh, okay, okay. Sorry, what's the question? Yes, I'm not clearly getting your question, but in this Synapse, you can spin up the Spark pools. So you can do machine learning and all those notebooks, Synapse notebooks you can write in the Synapse world.
My question is, because in hyperscale, you can set up a cluster and the cluster can distribute the queries and have this kind of model with multiple nodes producing the outcome and doing that the central node, the orchestration to produce the response. This one, my understanding is more efficient because Spark is doing the, the logic or the engine to produce the outcome.
Yeah.
That is why it's
Yes. So in the background, it's running the Spark the queries only. Yes. I don't know. I'm not getting your question. Maybe. It's an architecture. Yeah. Yes.
The SQL Server is there as well. How the data gets, I think, served. But the engine that actually returns that data accesses the data differently. So in a Synapse pool, Synapse was for saying, if you have any set of data in Azure SQL DB or Azure SQL, it scans the entire data set for you before returning the result. Right? Whereas in an Azure SQL DB or a dedicated pool, what it does is it actually moves data across different compute nodes. So think of it as it's moving data across different servers. And the control node will say, based on what query you give it, what control node has my data. To go and query that control node over. So instead of doing 10 hours worth of data, what you're now doing is putting that into multiple different small queries. But you're only accessing the system that you need that has your data you want. So it's yeah.
Okay. I hope it's clear. Your doubt or not? Okay. Cool. Thank you. So why we are migrating to Synapse? What are the benefits that you are going to get out of it? So first of all, these are the benefits that you are going to get out of it. As you can see on the screen, the Synapse are actually 90% cheaper than the competitors. Why? If you, I will come a little bit later. Why is cheaper? Why is it? Because you say Snowflakes give you charge per second, but Synapse charge you per hour. Then why it's cheaper? Because if you are running query for 5 seconds and you spin up the Synapse for an hour, you're getting charged even for 5 seconds. You get charged for an hourly billing. While in case of a Snowflake, if you run query for 5 seconds, you're getting charged only for 5 seconds. Then why? Why we are saying that the Synapse is less expensive than the competitors? So I'm going to talk about all those things in the detail. These are the few benefits. Security. Uh, we have inbuilt security available with Synapse. It's 99% availability across regions. Workload management. You can have the heterogeneous data or the homogeneous data that you can sit together. it's allow you to ingest data from the variety of data sources, whether it can be a SQL Server, Oracle, flat file, CSV, or anything kind of thing. And you can use your preferred tooling tool to connect to the Synapse. So you can use your management studio, you can use your Azure Data Studio, you can use your Visual Studio Code, you can use any kind of IDE to connect to the Synapse. The only drawback, if you are using Synapse on Management Studio, the IntelliSense is not going to work. So as soon as you type DBO dot table name, the table list of table names started popping up. That thing is not possible with the Azure Management Studio. To get that IntelliSense working, you have to use the Azure Data Studio. That's the product that Microsoft have bought. So this is a very common question that comes to mind, or the company who is planning to migrate the data from their on-premise or an Oracle to an MPP architecture. The first question comes, which platform shall I use, Synapse or Snowflakes? Generally, every company does this. They decide, they call the representative from Snowflake, they call the representative from Microsoft, they do the POC, and finally, and they decide which platform they have to go. So I went to the Gartner conference last month, and I went to one of the stall from Snowflake, and I've asked the same question to him, that guy who was standing there. Okay, can you explain me what's the difference between Synapse and Snowflake? Why would I prefer Snowflake rather than Synapse? Because I'm coming from Azure background, so I want to clear my doubts. And frankly speaking, that guy is not able to answer my query clearly. He is just trying to say that the Synapse is very,
Snowflake is the name of a company.
yeah.
But do they have data centers?
Yeah.
They
Yeah,
have-
that yeah, it's like a Snowflake. It's a software as a service. So
Are
you
they
can,
located-
yeah, yeah. So it's like a software as service. You can go to any cloud platform and can spin up the Snowflake there. While in case of Synapse, you have to log with the Azure only. So what's the difference between so first of all, I go into difference part and the dissimilarities. Let me talk about what's the similarities between those two. So compute and storage both are separate between hyperscale and Synapse. Uh, both Snowflake and Synapse. And Snowflake and Synapse, you can pause, resume the database accordingly. Both are NC SQL compliant. They can handle both structured and unstructured data. They both support the Delta Lake, uh, and they also have the RBAC rules upright, role based control access. They have already there. They also support MFA. They also support the virtual private network. So these are the similarities that can go on between Synapse and Snowflake. So what's the difference? Snowflake is nothing is a software as a solution, software as a service, whereas Synapse is a PaaS, platform as a service. Uh, Synapse pricing is a little bit complex compared to Snowflake. As I already mentioned, Synapse charge hourly base charge, whereas Snowflake's charge you uh, a second level, second at seconds. Snowflake has the auto scaling capability. So depend upon your workload, depend upon your query, it can auto scale and up and down. Whereas case of Synapse, you cannot do that. You have to manually scale up and down, whether you have to be 1000 DW, 2000 DW, 1000 DW. Serverless, you can do that, but serverless, you don't manage compute. You just look after the data and they charge on the per database things. Uh, I will come back to this question again. Serverless, when we can use serverless and when we can't use serverless. Azure Synapse requires more administration, so you have full power. What kind of administration you have to manage on your own? With case of Snowflake, this is come as a software as service, so you don't have much authority to go and change that settings available. Uh, also, if you ask me in which scenario should I use Synapse than Snowflake, so Synapse is a very an excellent choice if you are doing working with the machine learning, artificial intelligence, or data streaming. If you are doing this kind of tools, then I would say Synapse is your technology to go for. But if you are doing the proper normal traditional data warehouse, then you should go for the Snowflake. The good part coming with the Synapse here, because as it's a Microsoft product, it's gel with your single sign-on. So if you are having a Microsoft account and you are using this Microsoft account for any other Active Directories directly linked with the Active Directory, you can use your same account for to access everything. With that Synapse, with that Snowflake, that becomes a little bit difficult. So these are the benefits that you are going to get out of this from Synapse. So what workloads are suitable for Synapse? To store large volume of data. So there is no limit. Like with hyperscale, the limit comes 100 terabyte. With managed instance, it comes 8 terabyte. With Synapse, you don't have that limitation. So you can store as much amount of data you want to store. You can consolidate data from variety of sources into a single location. You can do shape, model, transform, aggregate data into Synapse. You can run batch or micro batches load. You can do your normal analysis data performance query across data set. You can do ad hoc reporting on the database. And you can all use your simple SQL construct statement that you have learned so far that is going to apply here also. So what workloads are not suitable for Synapse? If you are trying to build an ODS layer, an OLTP system, then Synapse is not a use case for you. Synapse is purely for data warehousing purpose. So if you want to use for ODS layer, then I would say Synapse is not the right choice for you. So especially if you have a lot of reads and writes on the database, large number of singleton inserts are happening, high volume of single row inserts. And if you're having the data type called XML, when you are trying to read data from an XML, the XML data type is not supported in Synapse. So those kinds of limitations are coming with Synapse. So if you are trying to use this type of use case, then I would say don't use Synapse. So now we have talked about lot about Synapse, what is features and everything. Now let's start talking about it's the migration part. Like how can we migrate this data to from on-premise SQL or an Azure SQL to Synapse? So the the strategy is play a very important role. If you don't have the proper strategy that how you're going to handle, most probably you are going to go overrun your project. You are going to spend over extra on the project. So the pre-migration is a very important step in any project if you're migrating data, especially in a data migration project where you're migrating data from one place to another place. So before you start, make sure do your analysis. What codes are compatible in Synapse? Synapse is a SQL version, but there are certain features which are not available in Synapse. You have to think about if those components or those codes are there in your existing code, then you can't migrate as it is. You have to think about some alternative solution. I'm going to mention about those things which are not supported. So pre-migration is very important. The second thing is the assessment. In assessment, Microsoft has created a new tool called Azure Synapse Pathway. This tool actually helps you to connect to your repositories, and you can just say assessment. It will provide you a lot of information. It will tell you what kind of codes are not supported in it. Synapse Pathway actually converts your schema and tables automatically to a Synapse compatible format. But it's not done yet for views, stored procedures, and other functions kind of thing. But what it can do at the moment, it can tell you what features are not compatible. So instead of going each and every code line by line, you just do an assessment and it will tell you line 40 on this stored procedure is not compliant. Line 60 on this view is not compliant. So you have to think about now you've got the data where you have to actually look into it and start making that fixes so that this code becomes a Synapse compliant. So this is one of the best tool. You can do it by yourself if you want to go code by code. But we have used this tool and that's reduced our project duration a lot. Now, this is the very important thing. Now we have done the assessment. Now, how can we migrate this data? So first we started with the pre-migration, what things we have to achieve. We have decided, we have created a project plan, the sprint planning and all those things. Now we have done the assessment. Now we have to think about migrate. So in the migration part, we have to think about these 4 steps. Consider the table design, consider the code change, migrate your data, and consider workload management. Because when you go into Synapse, you are going from an SMP architecture to an MPP architecture. So consider table design. So especially you can have a table on your site, whether it's a fact, dimension, or a staging table. or you have a regular table, temporary table, or an external table, you have to think about what kind of table design you're going to have for those tables, whether it's an replication distribution, or it will be a replicate distribution, or it will be a round robin distribution. So before I go into much tech this thing, let me clearly explain what those three differences are: what hash, replicate, and round robin. In the hash part, it you can say uh, you have three boxes here, one, two, and three boxes, and I've got say 100 records, and I want to put that 100 records across those three boxes. So what I'm going to do first, I'm going to use the replicate. So I'm going to put 100 things into each boxes. So what happens becomes replicate. My data is present across all compute nodes. What's round robin? So what I'm going to do, I'm just going to put my first record in my first bucket, the second record in the second bucket, and the third record in my third bucket, and the fourth record goes in my the first bucket again. So what's happening? It's going round one by one. That's called round robin. So each bucket is going to have only 33 records, and one bucket is going to have 34 records. With hash, is going to do, you are going to put some date, a key column that you want to distribute. So you can be month, date, a primary key, or anything that you want to put. So you can use one of the column to decide the hash, and that hash is going to move the data across this buckets. So, if you want to find out what are the things that are not compatible in your current workloads. So if this is the simple query that I have shared on my screen, this is the query provided by the Microsoft itself. So these are the data types which are not currently supported in Synapse. So if you are having the image type, text type, and text type, XML data type, geography type, geometry type, then those data types are not supported in Synapse. So if you in your current world, in your SQL world, if you have this data type in your tables, that means those tables, those data can't be migrated to Synapse as it is. You have to change the data type. You have to change from XML to varchar. So it will store as a varchar rather than XML data type. And as you can see here, there are some workarounds available. So these are the data type, and what are the workarounds available? So for the geometry, it's a var binary, geography var binary, hierarchy ID is nvarchar 4000, image var binary, text varchar, and text nvarchar, and all those things you can define here. So Microsoft already provided you a lot of materials. Like if you want to migrate this from on-premise SQL to a Synapse, it's tried to provide you the alternative as well. So what kind of code change that you have to think about when you're migrating your workload from SQL servers to Synapse? So these are the places that you have to go and make sure that all your existing codes are compliant or compatible. Stored procedures, views, temporary tables, dynamic sequence, looping, grouping by options, variable assignments. Yeah. So we can do similar kind of index, like you can create a column cluster index, a non-clustered index. So whatever you have done on the SQL server side, you can create a similar kind of index on the Synapse as well. Yeah. Synapse supports both column cluster index and the cluster index, and on top of it, Synapse support one more index that's also support on the other lower version of SQL Server after 2016. It's called column store index, column cluster store index. So that's if you are planning to use that index, that's especially is very helpful if you have a large volume of data in that table. Condition: the table should have at least 1 million rows plus. If you have less than 1 million rows, the column store index is not going to be effective. It's only going to be effective when the table has more than 1 million rows in it. Mm, Uh, Microsoft best practices suggest that if the table size less than 2 GB, they prefer to be table as a replicate. Staging table, round robin. So if you have a lot of staging tables, then you should think about creating the distribution as round robin. If you have a reference table with less changing in data and less volume, because generally reference tables is not going to be more than 2 GB size. So those table can be replicate. Catch come with this: if you have a table with reference and you are updating that reference every day, what will happen that replicate index becomes ineffective because break the link. And as soon as you fire the query first time, that replication happens across all nodes. So if you are not, if the reference tables are not updating very high, like on a daily basis, then I would say replicate table with less than 2 GB, the reference table with less than 2 GB size should be a replicate distribution. Staging table, round robin, and your facts and can be your hash distribution. So your fact tables can be your hash distribution. Dimensions, again, I would say that depend upon the use case, whether you want to put on the hash category or on the round robin, not on the replicate. We have done the same thing in our migration process. So depend upon the thing, it's vary. Generally, if you ask me, I put the dimension as well as the facts on the hash distribution, but it will vary. So if you are a code having this kind of syntaxes in your existing SQL world, then you are in a trouble. That means you have to rewrite your code. These are the features are not supported in Synapse. So if you have written a lot of stored procedures, the first thing that we do in the stored procedure, drop table if exist, and give the table name and the schema name, because we don't want to first thing, if the table already exists, drop it and recreate. If you have that kind of syntax in a stored procedure, that is not supported. So workaround is that use if object ID exists kind of thing to overcome this. Grouping by grouping sets, grouping by cube. If you have if statement, at the rate server name. If you have a string aggregate functions and you put the data type where and where char max, because you don't know the length of the column, that is not supported. Primary key is not it's supported but it's not enforced. Unique constraint are supported but not enforced. uh, Left hash joins are not supported. With no lock, especially on the server pool, is not supported. Order by in the temporary tables is not supported. Ignore nulls is not supported. If you have all those things in your Synapse, it's not supported. But other than that, everything is supported. Yeah, I don't think the foreign key is supported as well. Yeah.
Just order by,
Which one?
order by is not supported.
If you are having a temporary table created in your stored procedure, and you inserting data into a temporary table, and in the and you are putting order by, because you want to put a data into a temporary table, and if you're doing order by, say, column A, B, C, or whatever it is, that is not supported. So if you're putting that data into a temporary table and trying to order by before it goes to the temporary table, that is not supported. Dedicated pool supported, serverless pool is not supported. Yeah. So that's the reason I've specifically mentioned, if you are using serverless pool, that is not supported. That with no lock is supported in dedicated pool, and generally we use this query to not put a lock while reading the table. So now think about how to migrate. So we have learned about what codes are not supported. Uh, Now how to migrate this data. There is no in-house tooling available from Microsoft that can lift and shift the data from SQL Server or to the Synapse, like backup and restore. That you can't do with Synapse. So you have to create some kind of pipelines or ETL jobs to migrate this data from one place to another place, or you have to put this data into some in a flat files and do the polybase kind of thing. So what we have done here, we have built a pipelines, ADF pipelines, which allows to migrate this data from SQL Server to on-premise, to Synapse, and that migration can take a long time. So there are these things that you can use. You can use the BCP bulk copy program to migrate data from SQL servers to Synapse. You can use the polybase feature to migrate this data from SQL servers to Synapse, and or you can create your own ETL pipelines, and that you can load into the Synapse. And the another concept comes with Synapse is that workload management concept that is not possible with Azure SQL DB. So first thing important is that you can do the workload classification. So what is classification? Classification is nothing but you classify your workload. In a simple language, there will be two types of workload: a loading where we are loading the data warehouse. And the second classification is query, reporting queries. So that's a simple classification that I have on that one. So you can classify the workload, and you can put some two types of classification available, whether it's a static or a dynamic. If it is a dynamic, you can have the starting from small, medium, large, extra large RCs, and with the static, you're starting from a static 10 to static 80. So those kind of classification are available depend upon the use case. As soon as you do the classification, the next important feature comes is the importance. Like how important is your query? So if the query comes from the CEO and if the query comes from the data analyst, the query from the CEOs take the precedence. So that kind of classification importance that you can do on the workload importance. So there are 5 kind of workload importance available to configure. It's the 5 kind of importance that's available, which is the low, below normal, normal, above normal, and the high. So the request coming from the CEO machines, it considered as a user, it considered as a high importance. And the workload isolation, that's the last important point. So when you have a Synapse, you can do the workload management, the isolation also. So what you can do, if the query coming from this group, from this user, I want to give the 50% of the allocation to this user so that they can run their query effectively. But there is a catch. In the absence of workload isolation, requests will operate in a shared fashion. So whenever the request comes, access to the resources in SharePoint is not guaranteed and in assigned on an important basis. So if you don't have a dedicated environment to run queries, if you don't have the classification whether how much maximum you can go and how much minimum you can go, in that case, what happens? It will run the query in a shared fashion. Conferring the workload isolation should be done with a cautious, as the resources are allocated to the workload group and they have not using that, that means you are wasting that resources. So whenever you are doing this workload classification, you have to be very careful, like how much the volume that they're trying the resources they are going to use. If you don't do the proper planning and proper resourcing, then that's going to be wasted, the resources, and the overall optimization or the utilization of the system goes down. So what are the best practices that we should look for? The best practices for the dedicated pool in Azure Synapse Analytics that you should look for: reduce cost with pause and scale. So if you don't need a dedicated pool 24/7 running, if you just need for delta load, say 4 or 5 hours, you can scale up before your delta pipeline start and scale down after the delta pipeline finish. That way you save a lot of money. You are just paying only for the storage cost, not for the compute cost. If you think, no, I need this 24/7 because this is my production environment, I need that query to be available, but not on the same DWU. So what you can do at the beginning of the pipeline, you can scale to the 1000 DWU, but at the end of the delta load, you can scale down to 100 DW or 200 DW. So you will save a lot of costing. If in terms of costing, how much difference is going to cost difference? So if you are using 1000 DW, it's going to cost you approximately $23 an hour. And if you go to 500 DWU, so it's just half of it, $11 an hour. 300 DW, just half of it, $6 an hour. 100 DW, $2 an hour. So this is how the cost is increasing. So if as you go on increasing the DW, the cost is going to go double and double increase. So make sure if you're not using, think about either scaling or pausing the resources. Maintain the statistics. If you are doing a lot of inserts or updates on the database, make sure you have the DBA kind of activities who update the statistics on at least weekly basis. Otherwise, what will happen? The query plans is not going to have an update statistics, and the query performance can impact it, and that can take more time. So make sure you start taking statistics as well. Performance tuned queries. You can create indexes to improve the performance queries. Group inserts into batches rather than doing single inserts. Do inserts into batches. Use polybase load and export data quickly. So when you're trying to load data into Synapse, there are 2 features available in ADF pipeline: bulk insert or polybase, and there is one more called copy into. So if you bulk insert, the table will be logged and goes direct like in a normal bulk insert fashion. With Polybase, what will happen? It's not going from database to database. It stays that data into a file format called Parquet, an internal format, and from there it goes to the Synapse environment. So use Polybase feature. I can assure you that if you have a large volume of data, which is say example I can give, I was trying to load the data for 4 billion rows in it. And when I tried to load data through a bulk insert, that table was running close to 4 days or something. And it's impossible to wait for 4 days, and because it's a big volume of data with the large number of columns as well. And we have used Polybase, and the time has reduced from 4 days to 1.5 days. That kind of importance, that the benefits that you are going to get out of it. Use hash distributed large tables. So if you have a very big tables, then try to do partitioning correctly. Use hash. Do not do over partitioning. Minimize transaction size. If you don't do too much of a commit size, like say commit after 100,000 rows or 1 million rows, so don't put maximum. Otherwise, what will happen? The temp DB is going to scale up, and that your system is going to crash. Use the smallest possible column size. Just don't create blindly. If you need a varchar 50, just don't create varchar max or varchar 255. If you need only 40 characters, limit the size of the column. You with Synapse, lot of DMVs also coming. DMVs helps you to monitor and optimize your query performance.
SQL Server,
Yeah.
and they work.
Yes. So in summary, so what's Synapse Unified Data Platform? So it's a combination of these four services: Azure Data Factory, mapping data flows, Power BI, and SQL Pools. You can query on your own term if you are on a serverless pool only. So you can query on your own term. So you don't have to dedicated pool environment available. You have a seamless Spark pool where you can write the Spark notebooks either with your preferred language, SQL, Spark, Python, whatever it is. With Synapse, you can create a link for the Cosmos DB, and it's purely seamlessly integrated with the Power BI. So if you are planning to use, then I would suggest that these are the main reasons that you should look for migrating your workload to Synapse. From my experience, we are using a lot of standalone systems that were running before, ADF, Databricks notebooks, and the Power BI. So what we have done, we have bought all into one umbrella. Now we don't have to go and things around. So once you log into Synapse Workspace, you can actually connect to the Power BI dashboards directly. So you don't have to go to the powerbi.com or something like that, or you don't have to go to the.
So in Power BI, we can set up a link to the dedicated pool.
Yes, you can.
I think there's some deeper integrations going
In Synapse. No, no, no. If you want to make changes or create a dashboard, so you can do directly in Synapse itself. Yeah, so there is you can link, yes. Mm, yes.
So how hard is it migrate to Synapse?
Okay. If you have done proper planning and analysis, that's not hard. Hardly 1 month, if I have to say. If you want to migrate your all workload from SQL Server to Synapse.
And what are the challenges?
So as I mentioned, all the challenges are mostly around the SQL code. These are the codes. If you have this kind of codes in your current SQL scripts, then these are the major challenges because that's not supported. The next challenges that you are going to face is on the distribution type, because when you create a table, it's going to create by default as a round robin. So you have to create with the proper distribution, because if you don't have a proper distribution, the query is going to take more hours. So you have to decide the proper distribution type on the tables. So these are the few challenges that we have encountered when we are migrated from SQL Server to Synapse. For what?
Yeah, there's some DMVs
Yeah.
that you can monitor that will show you if it's doing a lot of data copy between the nodes and things like that, and that'll
Yeah.
give you a hint that maybe your distribution isn't correct.
If you
So-
see if you see those, they're called like a shuffle operations.
Yeah.
So if you see those ones are bad.
So three.
Start from 500.
Sorry.
This question starts with 500 views.
No.
On your table, it was like one. We have one instance.
That's the only that's the compute node. Yeah, but not the distribution on the tables.
You still have 60 distributions across one node.
Yes.
We still say.
Yeah.
There's always 60 databases,
Yes.
effectively 60 databases. It's the number of compute nodes out the front that change with the DWUs. As you go higher, you get more compute nodes. As you've added.
Sorry.
last 8 hours, you replay those out of the lake.
Right, we'll take 2 more questions for Suraj. They have to be easy, you know.
It's about the cost benefits after the migration. So is the environment faster and cheaper?
Yes. Not cheaper, but a little bit expensive. But you are getting a lot of benefits out of it. The first thing is that the delta load duration, which was taking 4.5 hours, now reduced to 1 hour. With that, we can do the machine learning things on top of it. We can connect to the query, the SQL Server database, like the blob locations through Synapse, through an external table. You can create the cost. Performance is one of the main benefit that you are getting out of this Synapse. Cost a little bit expensive, but you're getting a lot of other advantage that you getting that ADF into same umbrella. You're getting the Power BI things. So all those benefits are coming with Synapse.
So each of them doesn't support geography or geometry. It doesn't support the fact you can just have well-known text entries, and so the SQL queries too can't do any geography or geometry.
No. So you can't have that data type table created with that data types. So if you want to migrate the data type from geometry or geography or and text into Synapse, you have to create as a data type as a var binary or as a and text. Sorry, and
String.
varchar.
Yeah. So
Yeah.
like a chart.
Yeah.
Character.
Or if
Convert the
you-
string, store them that way.
Right, so probably, so where you've got a polygon, where you've got a variety of points, you can use the well-known text construct of that, so.
Yeah.
And the queries will understand that. That's probably the bit I've got, is that you may be able to get
Yeah, you store the text
yeah.
and then you're talking about bringing it back into Power BI and putting it in a visualization.
Just doing some-
You'll write some fancy, someone like you'll just create some fancy DAX to convert it from spring back, right?
You alluded to, you posed us the question with regards to, how can this be cheaper than Snowflake, with Snowflake times per second, the hour, and you said that it was cheaper. Can you allude to why it turns out cheaper than Snowflake? And I suppose it's for the same data footprint, for the same workload.
So I don't have much experience on the Snowflake, frankly speaking. I never worked on Snowflake before. We have done the small POCs to comparing the Synapse versus with the Snowflake. What we have found at the overall project cost that we have charged, we found that the Synapse is coming on the lesser side compared to with the Snowflake. So frankly, if you ask me this question, I'm not the right person to answer that kind of question.
Yeah, just that you mentioned.
Yeah, and I don't have much experience on Snowflake, so I can't answer that one. Yeah.
You do, while you
Yeah, everyone I talk to about Snowflake, they don't actually talk about Snowflake. They talk about these like these data sets that are just there. And I've asked.
You could just go in.
There's no one from Microsoft in the room, is there? No.
You
I've asked Microsoft about, are you gonna head down that road? And they just pretend I'd never even talked to them. Like, they pretend they didn't hear the question, but they're well aware that that is one of the things that is killing them
It's
in
quite-
that Snowflake.
It's quite nice that you can basically write a query. You've got, I don't know, repetitive data. Select star from their table, join it with my table.
Yeah.
But it's got the same issues as this, I think, where we had a few vendors trying to update their data daily and they actually fell behind. They couldn't keep up because the OLTP side of it, they were really struggling and
Oh, because they're talking about,
like, it's hard to update.
Yeah.
okay, well, I got the impression that they were trying to have like stream analytics, some high volumes being able to come to it.
I'm not sure.
Early on stage. The bit I liked about it, I don't get on the tool as much, as the security model where you can do roll up accesses roles into a role and you can tune across the tables much easier to what I would call SQL.
Same thing that might be in Fabric.
I'm sure it will be. There's a geometry.
Fabric is the Synapse, like
Sorry?
how different the experience of the Synapse. So I have seen that in the Fabric, they just also show this experiences of some of the components of the Synapse, like data engineering component, the notebook components, all this I saw in Fabric. How different do you think that experience will be in Fabric than what you have experienced in Synapse?
Maybe I'm not the right stage to answer that question because I haven't looked much into data fabric. David, you want to take that question?
Setting up a greenfield environment, do it in Fabric. So that means something.
So Fabric is due to October. Or spring.
Yeah,
Ignite or SQL Pass?
yeah.
And
That's
what's
nice.
the red for next year?
Yeah.
For it also, Suresh, we told Suresh before this session to change Synapse to Fabric for the next presentation. Just the name, you know, the same deck.
Now,
Yes,
Same plan.
Yeah.
yes, they do the Spark analysis, the SQL. What's the other four? What's the other two on that layer above the one lake?
So it's Data Explorer.
The Data Explorer, and there's one that's not available yet.
It is the new AI auto alerting.
Yeah.
The
DBA replacement. I think.
Like
The latest database administrator replacement.
Activator. or something.
Activator.
ah,
All right, guys, thank you, sir.
no problem. Thank you.